All right, good afternoon, good morning. It's August the 9th. This is our third interview with Burke Brown. And Burke, you started talking about the journal that you've kept for years. Perhaps you could tell me a little bit about how you got started journaling and what it is you've been doing. Perhaps most recently, what have you been writing in your journal?
All right. I was introduced to journaling when I was in university and graduate school, and there were two things that occurred, and I've been very grateful ever since that I've had the journal. The journal is not a diary in the normal sense of the word. The journal is a way of my talking to myself. It's closer to research notes that a researcher would have in his laboratory of the research he's doing, although it covers more than that. It also is similar to, we'll say, Columbus's log when he was going to discover America. I use the journal to problem solve, and as I said, it's been a godsend to me, and I would love my children and grandchildren, and of course anyone who's interested, in particular those I love, because there's a lot in the literature on the benefit of journaling. It takes a while to get used to it, but once you do, it's an excellent tool to help you decide where you're going and how you're going to get there, and to face the various problems that you have. Now, I started it, as I said, for two reasons. One of them, there were two professors that gave me problems in my graduate school, and it's the lesson in it that both of them, who gave me problems, gave me almost irreplaceable benefits. It shows how good comes from bad. The one who gave me most problems, or the only one who did, in my master's degree, was a chap by the name of Bovard, who unfortunately I think ultimately was, I'm not sure, but I think he was put into a mental institution. I think psychology attracts us. I was getting first-class marks in everything except his course in physiology, and I complained to my thesis supervisor, and he assured me, he said, "Don't worry about it, just don't pay any attention to him." But mixed up in his idiosyncrasies was a certain genius, and he recommended to me that I start journaling. That would perhaps not be sufficient. He suggested that because of writing skills, but it turned out to be much more than that. The other reason is that I was intrigued by a researcher by the name of Hull, H-U-L-L, and I believed that what he was doing would come to naught, but he was extremely thorough, and since he ran his lab and kept these journal notes, I thought I would do the same thing.
What was it he was doing that you thought would come to naught?
Well, in psychology, many of us who are interested in research in psychology suffer what I think could be called physics envy. We would love to have the success in psychology and understanding human behavior that physicists have had in their field. And Clark Hull was such a person. He believed that he could attack the field of psychology in an analytical way that was similar to the way in which a physicist attacks his work. And it was directly evolved from Pavlov's work on conditioning. And he went into great detail in terms of learning theory, and not too much theory, but in the way in which we learn. And I think I could tell by the intricacies of what he was doing that it just would not catch on. And as often happens, there's merit even if it turned out not to be immediately beneficial. And I was intrigued with him. He also was very interested in hypnosis, and I was too, so I was interested in his work on hypnosis. The other thing, he was quite driven by wanting to make a mark for himself in his field and go down in history, and that was rather interesting to me that he was motivated by that. Anyway, I'm very pleased that I started the journaling, and when we may come back to this, David, but there's a bit of a lengthy story. After I got my master's degree, and I would have liked to have gone on for my doctorate, but for various reasons, one, money, is that I was married, I couldn't see how I could support a family. Other reasons too, I couldn't have the independence I wanted if I was going to have encounter people like Bovard and such. And I didn't know really what I was going to go do with myself. And it so happened, because of some good luck, Sid and I ran Ensign Motors. But in the time that I was down there, I continued journaling, and I said I didn't go through university to land up in the car business, although there wouldn't have been anything wrong with it. So I used the journal to think my way through what it is I wanted. Now, as a psychologist, of course, I would love to have had the success Einstein had. I didn't stop to think, one, did I have the brain? I don't have that brain. Can you find things in psychology anywhere comparable to physics? If you did find them, could you in any way communicate them? All these things, as a naive youngster, I never even bothered thinking about.
What are the characteristics of those concepts and theories in physics? What are the characteristics that are different from the work in psychology?
Well, rather than different, I'm going to start out, if you're going to find out anything, it's going to be contra common sense, or else you wouldn't be looking for it. And if it's going to defy common sense, it's going to be quite troublesome. It's troublesome enough in the field of physics. And if you look at the psychological effect of both quantum physics and relativity on the physicists and on philosophers in general, it's quite illuminating, and also a warning for what to expect if you had the same success in psychology. Now, your question again, what were characteristics?
The characteristics of the theory or the theorem.
Or the differences?
For example, the role of experimentation in physics versus the role of experimentation in psychology.
Well, because of physics envy, many of the much of the research that's done in psychology tries to emulate the precision involved in physics. This is a lengthy conversation, but the major difference here is that in physics there is measurement is readily available, and that's essential. If you can't measure, it's very difficult to make any progress. In the field of human behavior, measurement is indeed a very real problem, and there's a long conversation. I don't want to get involved in the philosophical.
I think the point I was trying to get to was, if a law exists in the field of psychology, similar to the laws of physics, then the mathematics, the statistics involved in proving it, or in the experimentation that would prove it. For instance, with Einstein's E equals mc squared, it has been possible to make measurements and basically prove the existence of that formula as a law.
Well, it's odd that the two fields, first of all, the separation between the fields are quite artificial. Psychology and physics, in many respects, should not be delineated, and that goes for all the disciplines. All the disciplines overlap. All of them involve human behavior. They're individuals doing the thing. in the case of both psychology and physics, in many respects, have landed up somewhat on the same planet, in that prior to the 1900s, by and large, the physicists and philosophers believed that there was simple causation, A cause B, and that was a certainty. It referred to as a very deterministic world. And with the advent particularly of quantum mechanics and quantum physics, that went out the window. That degree of certainty went out the window. And that is a feature of one of the things that we're focusing on here. So the major difference in the 20th and 21st century science is the fact that certainty has turned into uncertainty. But the paradoxical thing underlying uncertainty are certain patterns. We can't predict with a complete certainty, but we can predict with a high degree of probability. In the history of physics, oddly enough, social science made a contribution. And despite the fact that we as psychologists envy physicists, the Maxwell picked from psychology or sociology the fact that there is a regularity in patterns involved in human behavior and measurement with regard to humans. And how that originated, he used in evolving his thermodynamics of gases. So where most people think that physics preceded psychology or sociology, actually in the event of modern science, actually the social sciences contributed first. But that's...
I didn't know that.
Yes.
Can I take you back to the journaling then?
I think I should finish.
Okay, go ahead.
I think we should finish what we're talking about here with psychology. Both physics and psychology, or the social sciences, are dealing with uncertainty. And the whole manner and focus of everything we're doing is the fact that all of us have to deal with uncertainty. And in the 20th century, great progress has been made. But unfortunately, unless you have a certain amount of training, you don't know how to use it, and that's not adequate. The major thing we're dealing with on this dialogue is how ultimately everyone can have the ability to deal with uncertainty. So there is an overlap. I don't think I've answered your question well, but carry on.
I think perhaps we'll come back to the topic of laws in the social sciences, because I know that lies at the heart of your work. Could I take you back to a little bit more of a discussion on the journaling? And you've explained how you got started in journaling.
Yes.
What I'd like to know is, over the years, what is it that you've used the journaling for? And then most recently, where has it made a contribution to your work?
Well, over the years, I guess it would be fairly safe to say is, what's the problem? In other words, what's troubling me? If I can get clarification as to what the problem is, the saying that getting clarification of a problem is 50 to 80% towards the solution of the problem. So I would wake up with ideas, and I would be saying to myself, what's the problem? What do I want to accomplish today? I had too much to accomplish. How do I organize it? How do I deal with the complexity of it? And it was by and large a dialogue with myself. Later on, I actually carried on dialogues. If I had a problem, say with Laurie or my children or with someone else, I would play both roles, and I'd write it as a play, and insight would come from it. It was extremely beneficial for me after I lost Laurie, because I carried on a conversation with Laurie, playing both roles, and certain insights occurred that were extremely helpful for me. But
what conclusion would you come to on a day that you're journaling when the problem is too many things to do? What would the end result be?
That perhaps was the major problem throughout my whole career. And very early in my career, I learned something that's been invaluable to me, is make a list of everything it is that I think I have to do, arrange it in order of importance, do the first one until it's done and forget all else, and suffer the consequences. It's like living in a dirty house, but you have to do it. And I learned, of course, in writing examinations, take a look at all the questions, do the easiest ones first, or else if you start doing the hard ones, you'll get stuck and you won't get anywhere. Well, almost similar to that. So to this day, I do the same thing. Now, later on in my career, because of a number of chance events, I came across Ashby's concept of requisite variety. And this is one of the detriments of our field. It's not only our field, but the fields overlap the general systems theory. But all of us are faced with the difficulty of dealing with complexity. And what most of us are not aware is that our brains are not sufficiently complicated or complex enough to deal with the complexity faced in our lives. We have no alternative but to find ways around that problem. Ashby, unfortunately, Ashby's law of requisite variety, very few know it, fewer pay any attention to it. It's one of the most important observations in the field of social science. As an example, if you have a football field and you have equal players on each side, the complexity of the situation is equal, roughly equal, depending on the ability of the thing. But if you remove two players from one side, you know the chances of that team winning goes down extreme amount. So it means that in order to deal with complexity, Ashby used the terms you either have to absorb complexity or you have to attenuate it. Both, you know, the damn problems of this psychobabble. But what it basically means is that if you're trying to run a corporation, then the way in which and the tools available to you to run the corporation have to be as complex as the corporation itself. And one of the wonderful examples, it has to do with the Google and the growth of that search engine and the brilliance of the young people who did it. It's an excellent example of how complexity is absorbed because of the way in which they use neural networks and such of that. And they could deal with the immense amount of complexity that is out there and absorb it and deal with it. The computer is one way of dealing with complexity. As far as our own minds are concerned, we have no alternative than to live in a land of fiction, and most people do not know that. We live in a very real world, and we live in a world of fiction. It's very real. You're here asking me questions. You're sitting on a chair. You feel it. You're wearing clothes. You feel it. We got a camera. It's very real. But on the other hand, so are other worlds real. The world of the ant is real to the ant. The world of the moth is real. The world of the dog is real.
And what's the fictional aspect of human life?
The fictional aspect is that all of us are not living in a real world. We are all living in different worlds. And in essence, every one of us, no two worlds are the same. Your world is different than my world. In that we're not cameras. And what we see is what we've recorded up here, and we interpret everything we see. So when people talk about how bad man is, to me, the greatest mystery is how good man is. How in the world we ever get along, ask any husband or wife, but how in the world we ever get along is truly a mystery, and it's a miracle. But the major point is that we live in a world of models. It's a world of imagination. Einstein used thought experiments. And these models are effective if it permits us to predict with any degree of accuracy. And so in psychology, and I guess economics and various social sciences, what you're looking for is the best model you can find. Mm-hmm. And a lot of the topic that we're talking about here will have to do with that.
Is a best or better model one that has predictive powers? Is that
the better predictive powers? The mm-hmm. model is of not very much use to you unless you can use it for prediction. And the better the predictive powers are.
So Einstein's law, E equals mc squared, existed as a theory and was proven, I presume, when the atomic bomb was created and actually detonated.
Well, actually, the history of that, and it took maybe over 30 years or more for Einstein to, for people to accept Einstein's work, and it's still being tested. And there are others still questioning it. Einstein had said that there's a relationship between energy and mass. And if that's the case, then, and he said that you could prove this by energy being attracted to mass, and you'd have to have great distances involved in this. Now, I don't know, this is my layman's interpretation, I don't know how correct I am, but basically, if, for instance, you could, if you knew a position of a star on the other side of the sun, and the light passing the sun bent, you would then know that there is this relationship because we know of the gravitational influence between objects. And so I think it was in 1919 there were two teams put together in order to measure at different places in the Earth the effect of the eclipse. Not the effect of the eclipse, but you could see the light being bent if you had an eclipse. And Eddington was one of them. And the measurement of this was what was contentious. And the end result was that the scientific community came to the conclusion that Einstein's prediction was correct. Einstein himself never believed that the energy inherent in matter or mass would ever be released. I think, if I recall, when he was asked by Teller and other physicists to go to Roosevelt in order to convince Roosevelt to launch this research of making an atomic bomb, the Manhattan Project, they went to him because of his credibility. And I think if he hadn't gone, Roosevelt may never have initiated it, and who knows where we would be today if he hadn't, despite the horror unleashed. But I think if Einstein had thought that the energy could have been released, he would never have gone. He was a pacifist, and regardless of what the outcome.
So if I may, that's a supreme example of physics and predictability in physics with the mathematical formula. In terms of the social sciences, you've often mentioned the pursuit of physical laws in the social sciences. Did your journaling lead you towards that pursuit, that of looking for order, laws like the laws of physics in the field of human behavior?
All right, would you keep that
Sure.
question in mind, because I just want to say that Einstein would not have perceived what he perceived if he did not conduct what is referred to as thought experiments.
Gedanken experiment.
Gedanken or thought experiments.
Yes.
Those thought experiments are extremely important. They're something that most often you cannot do in reality, but that thought experiment would in open up ideas.
Mm. Can you give us an example?
Well, Einstein, the most famous one of Einstein's, and I'm not going to be that accurate in recounting it, mainly it's a bit in one hand it's complex, on the other hand it's not, and that's my inadequacy. But Einstein referred to the happiest thought in his life. And the reason for that is that he was, in fact, I might be able to demonstrate it here. I have a copper tube. I didn't intend this. I have a copper tube, and I have a ball bearing. If I drop the ball bearing through, what do you expect will happen?
What I would expect is
Yes.
that the ball bearing will drop rather quickly out the bottom of the tube.
Right, and it does, okay?
Yes.
All right?
Yes.
Now, I have another ball bearing that looks identical, and I'm going to drop it, okay?
Let's have a look at this. Okay.
All right?
Yes.
Now, we can count 1, 2, 3, 4, okay? It didn't go through right away,
It dropped rather slowly.
all right?
That's a hollow tube, is it?
It's, yeah. And there's plenty of room in the thing. I mean, the ball bearing, you can hear it. It's
Right,
so it's not touching the sides.
There's nothing restricting it.
Right. So why in the world would this one, which it looks identical to the other one, take a while to come down?
Well, it's not sticky.
No. So here
So
we
what's the difference between the two ball bearings?
the two is the fact that one ball bearing is a magnet and the other one is not a magnet.
So when you drop the ball that's not magnetic, it goes through quickly,
Yes.
and the one that's magnetic goes through slowly. Now, why is that?
And I will state why, but it took a lot of history before this was found out. We have a copper tube, which is really comparable to a winding of a lot of copper wire. If you take a magnet and move it through a copper tube, you will create an electrical current. If there was a meter on the end,
Mm-hmm.
and there's some wires, we would show that the ammeter, so we're creating a current. The fact, nothing happens unless there's movement. If the
Right.
magnet is still, nothing happens. However, when the magnet moves, it creates an electrical current, and surrounding that electrical current is a magnetic field that is opposite to the direction in which the magnet is falling.
Hmm.
In other words, as it moves, it creates an electrical current. That electrical current in turn creates a magnetic field, or they're happening at the same time, and it's opposite. So it actually slows down gravity, and it floats down.
Now, is that an experiment that could have been conducted 100 years ago?
No.
Why not?
The first of all, you needed, I don't know how long ago the technology necessary to make copper tubes of this, but more importantly, this is a rare earth magnet. It's called a neodymium magnet, and it can take a magnetic charge that they couldn't anywhere. It's only
Very
the last
strong.
10, 20 some odd years. It's only in the last 5 years, or 2 years, 3 years, that this type of
So what did they do 100 years ago to theorize or prove a theory about magnetic fields that you can now demonstrate with that tube and,
well, for
and magnet?
this particular experiment or prediction of this was known as Lenz, L-E-N-Z. But
Lenz law, is it? Lenz law?
Lenz law, yes. But it's important to go back into the 1800s, because this type of demonstration, or a related demonstration, would have crowds of people with what they'd have, what they referred to as not scientists, but natural philosophers. And this is in, I should say, in the 1700s, and then it was a bit different in the 1800s. But because man had known for rather thousands of years that iron filings could be attracted to stone that occurred in nature, lodestone, that had these magnetic qualities. The lodestone, and by the way, this shows the relationship between the sciences. We'll come back to Einstein. Is that in order to comprehend what I'm trying to get across, the study of the history of electricity is important, because there is an analog between what we're going to get at and what happened in the field of physics. But
So there's an analog between the the study of magnetism in the field of physics and the study of human behavior?
Yes.
Okay.
Where in essence, in order, particularly Faraday's research, is that today all physics classes ultimately demonstrate the iron filings moving around a magnet. Maybe we'll do it on a demonstration, I'll bring it in. But the iron filings form a certain pattern. Now the examination of those patterns, both around a permanent magnet and around a wire carrying electricity, and from those patterns, actually Faraday discovered induction, which in turn has led to our modern electromagnetic.
Now, those patterns are static.
Well, I don't know if you'd say the word static.
Well, if you sprinkle iron filings around a bar magnet, the iron
Yes.
filings don't move, so they're
No,
static.
that part will be static.
But there must have been sort of a quantum leap forward in thinking when they could generate electricity from moving magnets.
Well, the discovery that movement was essential, nothing happens without movement, was a major
Right.
discovery. Now these stones are close in nature to what man found thousands of years
So
ago.
what are we looking at here? What are they?
Now they are imitation hematite. Hematite is a raw ore. Magnetite and hematite are iron-bearing ores. Lodestone, I think, relates to magnetite, and it occurs naturally, and for many years, centuries, it was referred to as a natural magnet. The problem and the discovery was how you're going to make what they refer to artificial magnets. How can you take material that isn't magnetic and make it magnetic?
Mm-hmm.
And that evolved quite an industry. Well, these rocks can take a charge. Now this is, I want this as a demonstration. Now they're polished. If they weren't, it would just look like any stone that you would basically pick up.
Mm-hmm.
But there is, this particular one is.
One of them will hold the other one. Just
Oh,
I
yes.
see, yes.
But not only that, if you have the opposing poles, the pressure between them is quite intense.
Mm.
As you'll see, if I do this, it'll really jump. All right, I can hardly hold it.
Yes.
Right. So this occurred in nature, and when they discovered that there was a pattern, the pattern of iron filings is a simulation of the force, because we can't see the force.
When you say pattern, that that the field, the magnetic field around the stone, there's a pattern, but it's invisible.
There's a force field.
Yes.
Around this, but it's not available to our senses.
It's invisible
We
until
can
you sprinkle
it's
iron filings on it.
It's still invisible.
Oh, I see. So the iron filings just show you the presence of an invisible field.
Yes, and that the field creates a pattern, but it is not accessible to our senses.
I see.
So it's only indirectly that we know this.
So does that field, does that pattern, which is invisible, is that an example of a thought experiment?
No, but I'll lead up to the thought experiment. Okay. In fact, I guess we should go into it because there's a bit of a digression for a moment. The problem Einstein had is that the theory at the time was that a magnet moving through the copper field by induction creates a current. But they thought that it was different. This is where I'm not sure myself. If the magnet is static and the pipe moves through it, they believed it was something else.
I see.
Right?
But in fact, it's the same principle.
And when Einstein, he said this really troubled him, that the theory at the time, the difference. And then he had an aha experiment.
This was the happiest thought of,
Yes.
the happiest moment of his life.
And in a way, as an illustration, although he never liked the term relativity, it's when he got the insight that what you see is dependent upon your position. If you're on the magnet, you would perceive the situation one way. If you are on if you're the pipe, you perceive it another way. And so that went into, we'll say, his elevator thought experiment.
What was that?
Well, to give you an example, if you're flying on a plane, you don't really recognize you're moving.
Right. Everything is moving past you.
Well, but let's assume that you don't see that.
Yes.
You walk on the plane, you're not aware of it.
Right.
Anybody down here says they're moving darn fast up there.
Right.
When you're in the plane, you don't know it.
Because everything around you is moving at the same speed.
Yeah. Well, you're in an enclosed field. You have no information.
Yes.
To tell you that you're moving.
Right.
So if for instance, you were in a falling elevator, and you didn't know, you didn't have any reference, you don't really know. Somebody else outside knows it's falling, but you wouldn't know.
Okay.
So that insight, that perception is dependent upon your relative position.
So what was Einstein's happiest thought then? What was he working on at the time?
Well, I don't know enough about to talk intelligently. I've read, but I don't think I could communicate it. But well, of course, he's interested with regard to the nature of light,
Mm-hmm.
and he was dealing with certain enigmas that were bothering science at that time, and he was dealing with the aspect of time.
Was this the early 1900s?
Yes. In 1905, I think he wrote 4 or 5 papers, just unbelievable papers,
Mm-hmm.
what's called Einstein's year. But the insight, which is a psychological insight, is that what you perceive is a function of where you're at.
Right.
And that related into this concept of time.
This also related to the speed of light, did it not?
Yeah.
He imagined, or he postulated that if you're traveling on a light beam,
Yes.
or you're in space and you're on a flashlight, and you're traveling with the flashlight, what you perceive is a function of where you are in relation to that light source. Is that correct? Something like that?
I believe it is. I can't profess sufficient knowledge other than reading knowledge and fascination to be able to communicate it
Okay.
clearly, David. But to me, the value, the analog value of what the physicists experienced
Mm-hmm.
with the paradox pertaining to light and whether it is a particle or it's a wave and how they resolved it,
Yes.
is an analog or metaphor for what
I see.
think is happening in human behavior.
So if the thought experiment then involves human beings as particles, and the behavior of those human beings in an invisible force field.
It does. It basically that's the insight that I had.
And your journaling over the years led you to that breakthrough.
You'd asked me, how I came to it. When I was trying to think my way through what I wanted to do with my life, and I knew that I could be relatively happy doing research and trying to understand human behavior, but money interfered.
Mm-hmm.
I said to myself, well, what would I want to accomplish? I'd like to find laws equal to physics laws. What inhibits me? Money. And if I had the money, what would I do? I'd go back to the university and conduct research along the lines of whatever my curiosity, how it had directed me. And inherent in that was an assumption that turned out for me to be actually false. is that the way in which to go about finding laws in human behavior was by being in the university setting, doing certain type of experiments. If I had done that, I would not have achieved what I set out to achieve. It would have been wrong.
Ah, so what did you do then as an alternative?
Well, what I did is that I came into psychology at the time when there was a philosophical era called logical positivism, but basically it turned out to be empty. But I was taught, because I was curious, what's science? What is the scientific method? To this day there is no satisfactory answer to those questions. But I was taught when I was there that science is a method of determining the relationship between variables. You have an independent variable and you have a dependent variable. And you design your experiment in order to determine whether the relationship is significant or is not significant. So I remember to this day, I'm sitting up in the office at Ensign Motors. We're running this business, and I'm journaling. And I'm saying, well, I'm troubled by what is it I want to accomplish. Well, I want to be free enough that I could have the luxury of following my curiosity, finish my doctorate, and do research in psychology. What's interfering? Money. So I said, aha, money is the dependent variable. Right? So I said, all right, then what are the independent variables relating to money? Well, I don't know. And this was important. Well, why don't I study the careers of successful men, successful people, and find out what the independent variables were? So I started studying the careers. I found out many of them were in the different businesses, a lot of them in real estate.
No correlation.
Well, I didn't see it, and all of a sudden I said, what do they have in common? I said, whatever they've got, they own a piece of paper. If they own land, they own a title.
Piece of paper.
If they own a corporation, they own stock. Right?
So what was the relevance of that?
Well, the point is that gave me the common element, right? Here,
piece of paper.
They own a piece of paper which they can transfer into money, right? Or can value it in terms of money.
Right.
So once I recognized that it was a piece of paper, then I said, well, what's the ideal piece of paper? You know, if I had an ideal piece of paper, what would it be? Well, first of all, it would be liquid. I could turn that piece of paper into cash in a moment if I wanted to, right? It would be safe. I wouldn't have to gamble, right? So it would leave me free. I wouldn't have to bother managing it.
If you had enough paper, yes.
It's liquid, it's safe, and it would leave me free. So I said, well, where is the ideal situation where I could get that? And I said, I know. If I could own a gambling casino. If I owned a gambling casino, I'm dealing in cash. It's liquid. It's safe, relatively safe, forgetting the mafia and anything else of that nature. And I've got, there is another aspect, there's the growth aspect of the thing. I want it to be able to grow so it can compensate for inflation. And these are, if my journal notes don't get thrown out, this will be there as a kid in his 20s. And I said, well, where can I get that? Well, a gambling casino. Well, I'm not going to get a what's close to a gambling casino? Well, how does a gambling casino make its money? Well, it gets people in there who don't know the laws of the game, or if they do know the laws of the game, they don't discipline themselves, or if they do discipline themselves, it doesn't matter. The odds are slightly in favor of the house, so they're going to skim. They're skimmers. Well, that's but. So I said to myself, who else are skimmers in the business world? Well, the banks are skimmers. All they want to do is get the money out there, your money, give it back to you, and take a piece off the top. The insurance companies are skimmers. The brokers are skimmers. Accountants are skimmers. Lawyers are skimmers. So, in essence, I wanted to get into the skimming business. because if by then I likely had read about old man Rothschild saying that love the money business, it's the only one that works for me while I'm asleep. So I became interested
You could call that Skimmerian logic.
Yes, yeah, very good. Skimmerian logic. So by then I said, all right, if we want liquidity, you're going to get it in the stock market. So that took me into studying what's going on there. Now there are a lot of chance events because I went into the investment real estate field, and by chance I did some investment banking deals, and there's history in it. We'll talk about that if there's ever time. And I had to make a choice. It so happened I chose the investment banking area rather than the real estate area. I likely, in maybe some respects, I would have better off to stayed in the real estate, but it wasn't of interest to me, and I had to do what fit with my personality.
So all of these experiences made a contribution to your breakthrough of human behavior.
Well, what it did, that if I'd remained in academia, and as many did, it first of all put me into an environment that is not readily available in psychology, and that is closer to astronomy, is that the data was there. Once you're dealing with monetary behavior, you have all these records of stock market behavior and other things. You've got data.
So is this what you were studying then, man's monetary behavior?
Well, what it turned out is that if you want to find lawfulness, because I'm trying to find laws, you have to have data.
Right.
If you can't measure, where are you going to proceed? So here, I didn't have to take the small type of artificial experiments that I would normally have to do in psychology. I could take the data that's there.
Like what?
Well, basically what's happening in the stock market, stock prices, auctions, the buying and selling intentions of the...
So what led you to looking at the distribution of wealth?
Well, first of all, the greatest problem we face is inequality. And I wanted to understand how in the world, basically, I came to the conclusion we live in one giant gambling casino. And in turn, there's great inequality in this. How is this inequality generated?
So despite all the efforts of government to move towards equality, inequality is the law.
Not only is inequality the law, if you take a look at the history over the last any time period, inequality is growing. It is not decreasing. And my thesis is it's growing because our basic beliefs with regard to inequality are fallacious.
So can you relate this back to magnetism and how you first perceived the existence of an invisible wave which creates the financial inequality?
You know, again, this has to go back to the question in psychology, and if I hadn't been exposed to this, is that a fundamental question in psychology for me was, how do you know? I mean, I'm going to come to a conclusion. How do I know this is so? How do I know it's true? Well, inevitably in psychology, once you get into it, you get into the field of statistics. And it's unfortunate that the field of statistics has such a bad reputation because, and the word is not a good word because it's a confusing word, it conveys different, but basically you want to arrive at a gambling decision. You want to know, can I gamble on the results of this experiment, and can I have a fair degree of confidence that A caused B by and large, or is it just by chance? So in order to operate as a psychologist, you really had to understand statistics. Well, it turns out for the vast majority of psychologists, they do not understand statistics. What they do know is they can apply automatically the statistical tests, and if that is so, they are satisfied.
Within a certain degree of confidence.
Yes, they are satisfied. Why are they satisfied? Because the journals will publish it, right? So it's almost the blind leading the blind. But very seldom have any of them ever studied the history, because
history of
statistics, because underlying this technique of arriving at a gambling decision is one of the most phenomenal discoveries in the history of man, that ranks with the discovery of the pattern of iron filings around a magnet.
Are you referring to the work of Galton?
Well, I'm going to come to Galton.
Mm-hmm.
What it really troubled me when in a statistics class they said that we'll accept this as being significant if it's significant at the 5% level.
95% certain.
Yeah. I said, well, why not 99.9%? What's magic about 5%? Well, I couldn't get answers from my people. You know, I couldn't get answers that were satisfactory.
Did you ever get an answer?
No, I really never got a satisfactory answer.
Wasn't it arbitrary choice by Pearson?
No, actually it was Fisher.
Fisher.
And to the best of my knowledge, and I stand to be corrected in this, roughly around 1936, and because he was kind of a father of all this, is that he, in a lecture, he said, let's assume 5% is the level of significance. Now,
and that started it all.
Yes, but it really troubles me, because it is only significant in the long run, and this is one-shot experiment. So there is another complication of time.
Yes.
And it was this type of thing. There are many things that made me, aside from not being able to afford to continue, this really troubled me, because here I've got a discipline that is built on a foundation that really my colleagues don't understand. And by the way, 30, 40 years after I came to that conclusion, it started getting into the literature. And
what did?
These concerns that I'm talking about.
Yes.
About the lack of significance tests. So here, the tools that I had to use in understanding human behavior were really dependent upon the history of discovery in the field of mathematics.
Mm-hmm.
And I couldn't, I mean, how in the world could I support myself and a family and live at the level that I'm used to living with questions like this? So here I am. I've got these questions, and statistics, often it's referred to in the field of psychology, or ANOVA, which is analysis of variance, and it's been referred to as the second discipline of psychology. And it troubles me to this day. But with this interest, I became interested in the history of this subject matter. So here I am now. I'm out in the real world trying to make a living. I've got this background in the field of psychology. I'm troubled by the stat. And in turn, what do I find is that, in essence, we have what we call the random behaviors of stock market pricing. In other words, and this all ties in with what I had learned about statistics. So here are two things coming together. And I'd have to check back in my notes. But I did ask at one time a question, is what would happen in a theoretically perfect game of chance? Everybody starting off evenly and everybody playing rationally.
Now that's a thought experiment.
Yes.
And
that was a very interesting question.
So did you get to answer that question?
Yes, but what I want to mention here, though, is maybe about that time, I learned that it's important to ask questions, and it's most important to ask the right questions. How you can be certain you're asking the right questions is something else. That, for a youngster, was really quite a lucky question. You know, what go to a theoretically simple game of chance? And what I said, all right, let's take coin tossing. And everybody starts off the same way. And
Everybody starts out equal.
equal.
In a gambling game where a coin toss is used.
Right. So let's assume for a moment that you had 100,000 people at a signal. They in turn tossed all these coins.
Mm-hmm.
And I'm going to do something that isn't really correct, but it's theoretically we'll do it. So after the first toss, let's say heads wins, tails loses, there are 50,000 people left.
What do they do with their money?
The
Goes into the pot?
no, it goes to them. In other words, they're tossing coins. Let's assume that they're tossing one other person.
Oh, okay. So
I mean,
I got it. So
Right.
heads wins, tails loses.
loses. So the guy who
50,000 coins go to the winners.
yes, okay,
So they now, each of those have doubled their money,
right,
essentially. Okay.
okay.
And then what?
We do it again,
Another toss, 50,000 coins tossed.
and
On average, 25,000 will get heads, 25,000 tails.
yes,
And then the winners with heads, they double their money again.
yes.
Okay.
And if you keep on going, at the end, say of 14 tosses or so, depending, you'll have one person who tossed heads, say 14 times in a row,
That would be the smartest person in the room.
supposedly. Okay. So
Now, that's a thought experiment.
it's a thought experiment.
And that's easy to understand, but how does that relate to a wave?
Well,
where does the wave come
Well, what happens with the thought experiment is let's graph this,
in? Ah.
right?
So
So
what do you draw on the graph?
So if in turn we have a graph with an x and y axis, and we have, say, money on the x-axis and the number of people on the y-axis, so everybody would be starting off, let's say they all start off with $10.
So
Right.
that is the distribution of wealth in a game of chance where you're tossing coins.
And where everybody starts off equally,
Everybody starts equal, yes.
all right? Now, so...
But after the first toss,
No, wait, follow for a minute.
Yes.
Though. But so you would now have a graph, if you can picture it. And by the way, this is on the blackboard downstairs that I wrote it in 1980, never rubbed it off. But of course it was written much before that. But so, and it would have been best to have shown this rather than just talking this way. But nevertheless, you have a spike, you have one line.
Mhm.
And then I visualized
So that spike means that everybody has the same amount of money.
yes. Then I pictured that if the game is a bit more complicated, I could see that that game could go from equality to inequality, symmetrical inequality,
Yes,
like a bell-shaped curve.
yes.
And those people with on the right-hand side of that curve have more money than the left-hand side, so they've got more staying power in that
Right.
game. And then I could see the game becoming more and more unfair, and instead of symmetrical, the curve being asymmetrical.
Right.
And then if the game comes to an end, it would be one person. Now, as far as a wave is concerned, is in essence in life that doesn't happen. The game keeps on going on and on and on. So you could see in this method, let's say it was countries, if you've got that amount of inequality, you're going to have a revolution.
Now that amount, you mean it's a skewed distribution where there's a large gap between the people with a lot of money and the bulk of the population with less money.
Yeah. If you take Bill Gates and Warren Buffett, they have among them more money than certain countries.
Yes.
So in essence, that inequality makes no sense whatsoever.
So if I may sort of
Yeah.
to wrap up this discussion, your journaling led you to asking a question about the source of inequality in the distribution of wealth.
I was actually looking for the secret to wealth, not the source of inequality.
Right.
It became, because one of the things, again, being in psychology, we study inequality.
Right.
We have inequality in IQ, inequality
Yes.
in height, inequality in weight. So, in essence, the same factors that are contributing to that inequality are contributing to inequality in wealth. And there's
So
no
the secret to wealth then is also the secret to poverty.
Yes.
And to understand it, one has to do a thought experiment that involves coin tossing. Is that right?
Coin tossing or gambling of some sort, yes.
Or gambling, like the game of Monopoly.
Yes.
And can you just tell me how this led you to the coin deal?
I think we're going to need more time for that, but what happened, and I don't recall exactly when, I found this on my own, is that I came across Galton's work and his invention of what he called the quincunx. Because Galton was interested in inequality. He may not have stated it that way, but he was obsessed, and unfortunately Galton was the father of eugenics. 1 minute. All right.
Could you show us the model? Because
this is a model that is in some respects very similar to what Galton did. We have pictures which we will photograph of the actual model downstairs.
So if I may then, you showed us this before.
Yeah.
Each of those junctions then where the ball goes one way or the other is like a coin toss.
It's like a coin toss or a decision in life. In life, yes.
And a series of decisions then produces a certain distribution.
Yes.
And that distribution varies depending on what?
Chance. In other words, born in a certain period of time, a certain gene mixes with a certain egg. You're born at a certain time in history. All of us, if we stop and ask ourselves, what role has chance played in our lives? It won't be difficult for any one of us to recount time and time again how a chance occurrence has affected us. So chance rules. And once I saw the mechanism by which it became meaningful to me that if I was going to get economic, by the way, I didn't know I found laws then, by the way. I wouldn't say, I'd actually found what I was looking for.